皆さん、こんにちは。今回は電話で行われる模擬コーディングインタビューの様子をお届けしたいと思っております。コードの説明をするときに、英語でどのような表現をしたらいいのかがわからないという声を聞いたので、インタビューは英語で、その後の感想は日本語で行いたいと思っております。では、A さん、よろしくお願いします。
よろしくお願いします。Okay, so you are giving an array of integers. Let's call this array as nums. Find the index that satisfies the following equations.
Okay.
Let me write down them.
Sum of similar sign. Sum of the all numbers smaller than index equal to sum of the all numbers bigger than index. Sum of the all numbers smaller. Okay.
So with this example,
Mm-hmm.
you will return 3.
Okay.
Because left sum, numbers 0, 1, 2, is sum of them is going to be 11.
Uh-huh.
At the same time, right sum of the numbers 4 and 5 is going to be 11.
Mm-hmm.
So index 3 is satisfies this condition.
Okay. What if there is like such index, multiple of them?
You can return one of them.
Okay. Let me think. And they are not sorted, right?
Yes.
And if that is empty, what should I return?
If it is empty, or if you cannot find such an index, you can return -1.
-1, okay. And can I assume all of the sum fits in the integer? Well, I mean,
Yes.
should I like consider when I add them, should I consider them to be long or big integer, or they fit in integer?
Just think about this will fit in the integer range.
Gotcha. Let me think. One.
Go ahead.
Yeah, one solution I have is pretty, I guess it's going to be n square. So we're going to look at each index and then calculate sum up to that index and sum from right to that index. So it's going to be the two nested loop. That is a n square solution. The better solution is pre-compute sum from left to right and pre-compute sum from right to left. And so that you can compare index from left just by O1, like just look up that pre-computed array and look up pre-computed array from the right, and then compare either of them. Then compare them and check if they are equal, and then find if that is equal, return the index.
Okay.
Okay, yeah, let me start writing. I will just call it solve. This is a base case. So left, pre-compute. me just like do the to loop. For this one, sum from left. This one is sum from right. And what I want to store is left 0 is sum from, so left 0 or sum left I is sum from index 0 to index I minus 1. And right I is going to be sum from index I plus 1 to nums dot length minus 1. So let me think. So if with this definition, if I want to get the left sum of index 0, I look at left 0. And if index right 0 is going to be index 1 to the end of the array. So I think that is good. Let me think. So yeah, I think that is good. So let me see. So starting from I, left I is going to be left I minus 1 plus nums I. So index I, when I equal 1, left 1 is going to be left 0 plus nums I. Does this make sense? No, it's not. Nums I minus 1. So when I equal to 1, left 0 plus nums 0. So left I is going to include nums 0. When I equal 2, left 2 is going to be left I minus 1. That is going to be I. So nums 0 plus nums 1. Yeah, so that looks correct for I. And then here, right I is going to be equal right I minus 1. No, I plus 1 plus I plus 1. Let me think about it, because we started from nums to length minus 1. It should be from nums length minus 2. So for example, if length is 4, it starts from 2. Length from 2. Right 2 is going to become right 3 plus nums 3. Okay, that looks good. And nums when I equal to 1, it's going to become right 2 plus nums 2. Okay, I think that looks good. So left I equal to right I. Okay, let me walk through the examples. So for example,
Okay.
this is a given array. It doesn't fit in this condition, so continue. So first, left is going to become, okay, I will do 6 of them. So I starting by 1. And here, left 0 plus nums 0. So left 0 is 0 and nums 0 is 1. So it's going to be 1. Now I become 2. We are adding a left 1, nums 1. So that is left 1 plus nums 1. So left 1 is 1 plus nums 1 is 1, 7. So that's 8. I3 left 2 plus nums 2. So we are computing this value. Left 2 is 8 plus nums 2. 0, 1, 2 is 3. So 11. 11. That is correct. Let me see. So left I 1 8 3 0 1 I equals 3. Okay, so this is index 3. So it should contain the sum up to here. Yeah, that looks correct. Now I equal 4. 3 plus number 3, that is 11 plus 17. And I becomes 5 plus 4, that is 17 plus 0, 1, 2, 3, 4. So 22. Okay, I think like left sum is computed correctly. Now starting from here, I equal length minus 2, 4. So starting from index 4, 0, 1, 2, 3, wait, 0, 1, 2, 3, 4. Okay, filling this one. So now here, nums right 5 plus nums 5. So right 5 is 0 plus nums 5 is 6. So we are putting 6 here. 3, 4. We are filling this one. Right 4 is 6 and nums 4 is 5. So 11. 2, 3, 3. I equal to 2. So 11 plus 6, 17. 2, 2, 17 plus 3, 20. And here, 0, 1, 1. 20 plus nums 1, 27. Okay, that looks correct. 6, 3, 7. Okay, so now I equal 0, starting from 0, comparing 0 and 27, it's not true. 1 and 20, that's not true. 8 and 17, that is not true. 11 plus 11, that becomes, so that is this one, 0, 1, 2, 3, 0, 1, 2, 3. So yeah, it's going to return I, so returning 3. Okay, let me think about what if it only contains one element. If the test case is like 1, I suppose in this case, it returns index 0. Is that correct?
Yes.
Okay. Let me see if my code works on that. So
Wait, could you say that again?
Yeah, if the given nums length is equal to 1, should the method return 0? Because
no, -1. Because we cannot find that index to satisfy the condition.
Okay. Let me think.
Yeah, I see what you say, because left sum equals 0, right sum equals 0. Yeah, I think either is fine.
Okay, either is fine. Okay, so I suppose my method is going to return 0, but let me confirm that. So left and right is initialized with length 1, and then for loop is not going to go, and then yeah, it's going to return 0.
With here, right?
Yep. Let me think if there's any other edge cases. If the array is empty, that is okay. If array is not defined, what if nums contains negative value? It shouldn't affect because sum is just sum. Yeah, I think this is a ON algorithm.
Okay. Looks good from me.
どうでしたかね？
すごい良かったと思います。問題のレベル的にはどうでした？
まあ、ここから発展させる問題が来るか、もしくは、もう一問電話面接なので、聞かれるかなっていう風な感じですね。
そうですね。まあ、だから電話面接だったら、なんかちょうどいい感じかなと思ったんですけど。
これと、あともう一問何か追加で聞くみたいな感じですかね。
そうですね。
はい。
あとは、なんかテストケースが最初に、もうちょっとあったらいいなとは思いました。
テストケースは理解を深めるためのテストケースってことですか？
そうですね。ちょっとしたエッジケースが多分、新井さんが出してくれた要素が一つだけの時とかがあるので、この問題の場合は。そこでも、後で振り返りの際にそこをなんか自分でおっしゃってたので、いいと思います。
そうですね。多分、エッジケース一番最初に全部見つけるの難しいと思うんで、僕は自分のコードを書いた後に、このケース、どういったケースでなんかバグりそうかなっていうのを見て、で、その時に、要素が一つの時はどうなるんだろうっていうのを、何を返すべきかっていうのを確認してなかったので、確認してっていう感じでしたね。
そうですね。あとは、同じエッジケースなんですけど、こういう、これですかね。
21、-1。
これでも多分、
はいはいはい。
このコードだと、インデックス0をちゃんと返すと思うんですけど。
そうですね。そうですね。
ちょっと簡単でしたかね、新井さん。
いや、でも多分、どうなんですかね。どれくらいのレベルなんだろう。ちょっと僕は時間をかけすぎたかなとは思いましたね。
やってて。
はい。特にこのレフト、ここのレフトのインデックスのところは、ミスりたくなかったので時間かけましたけど、
はい。
ちょっと、テストケースを歩くときに、もうちょっと自分の中で、これを小さくするとか、同じような、例えば要素3つのあれでやるとかしたらよかったかなっていうふうには思いますね。
そうですね。コードを実際の、例で見ていくっていうのはちょっと難しいところですよね。いつも思いますけど。時間かけすぎてもいけないし、全くやらないわけにもいけないしと。
そうですね。そんな感じですかね。
そんな感じですかね。
はい。ありがとうございました。また次の動画でお会いしましょう。